This is part 4 in the multi-part screencast series, Refactoring to a Solid Foundation, whereby we explore the solid object-oriented design principles by applying them to an existing software product in an attempt to refactor it to an improved design using the techniques that S.O.L.I.D espouses. In our previous installments, we investigated the single responsibility principle, the open-close principle, the Liskov substitution principle, and that takes us to the I of S.O.L.I.D, the interface segregation principle. Stated simply, the interface segregation principle says, clients should not be forced to depend upon interfaces that they do not use. So this is a very simple concept which essentially says interfaces should be thin and not fat. So if you have an interface that has 20 or 30 methods defined on it, then in all likelihood, not all implementers of that interface are really going to need every one of those methods. This leads to the introduction of things like the not implemented exception being thrown, for example, inside methods of classes that implement particular interfaces, but only need some subset of the overall interface. In this scenario, we want to approach solving the problem by breaking down large fat interfaces with many methods described on them into a combination of smaller interfaces, each with narrowly targeted collections of interface methods, each one designed to solve a specific problem. We'll apply this principle to our software engineering project here in an attempt to better understand how this practice can help improve the design of our software. We're here in Visual Studio 2008. We have our previous solution open from our prior screencast installment. What we're looking at now is the class diagram that we're going to use to explore the interface segregation principle in this installment. In order to get things ready for this installment, I have slightly enhanced the class diagram from the prior screencast installment. Let's take a look. We've taken, if we zoom in here, and take a look at our data access methodology, what we'll realize is that where we used to just have a data access class with a single method called getData, we have instead introduced some complexity into this part of the object model. Instead of having a single data access class, we now have a report data access instance class. Concrete class. We have a data access abstract class with 3 methods on it, and ultimately that implements an interface we call iDataAccess. If we look at the root of this inheritance hierarchy, starting all the way at the iDataAccess interface, what we'll see is we've got 3 elements defined. We have a saveData method, we have a queryData method, and we have a getReportData method. So this is the iDataAccess interface, simulating a fairly fat interface in our object model, where somebody decided that it would be a nice idea to abstract all data access behind this interface. Unfortunately, this interface does a whole lot more than it probably needs to, because ultimately what we're going to see, if we take a look at our data access abstract class, is that because it implements the iDataAccess interface, of course, it's got these 3 abstract methods: saveData, queryData, and getReportData, which is fine. But the problem we end up with is that when we finally come time to produce our concrete class, which is our report data access class, what we realize is that our report data access class really only needs one of these methods. It needs the getReportData method. Unfortunately, however, because it derives from our data access abstract class, it needs to provide overrides for the other parts of that abstract class. So we've got the queryData method, which simply throws a not implemented exception, and the saveData method that also throws a not implemented exception. This model in the existing software will work and run. To prove it to ourselves, let's go on ahead and hit F5 and just run the application. Sure enough, here's our console app. It does getting data, it does formatting the report for 11 by 17, and then it does printing report to dot matrix printer. So what we see here is that the application still behaves exactly the same way it used to at the end of our prior screencast installment. However, what we've done is, because of the inheritance hierarchy that we have here in our existing object model, we have some extra implementation that we really don't need. And so right now, our report data access class violates pretty substantially the interface segregation principle. It is in fact forced to implement all kinds of methods that it doesn't really need, like queryData and saveData. And so what we're going to do now is refactor this in order to solve this using the interface segregation principle. So to get to the root of fixing this problem, we need to get to the root of where it started, which is in our iDataAccess interface. So our iDataAccess interface right now is symptomatic of what we call a fat interface. It does too many things. Now, at first glance, it may seem reasonable for all of this to be in the same place. In this particular case, we've got certainly just data access elements or data access methods inside our iData access interface. However, there is a clear separation of what's going on here. Some of these methods are about really interacting with the database for the rest of our application, and one of these methods, getReportData, is really about interacting with the database for the sake of running our report engine. So what we're going to do is we're going to refactor our interface in order to separate it out, in order to segregate its responsibilities. So we're going to take the iData access interface and we're actually going to create an additional interface. So we're going to call this iReportData access, like so. And what we're going to do is take the getReportData method and move it down here. So what we've done is we've collapsed a little bit the iData access interface so that it's really now a generalized data access interface for saving data, as we can see right here, and querying for data in the database that the rest of our software application that isn't about reporting might very well take advantage of. However, we've introduced this new interface, iReportData access, that only has the data access method that requires us to do the getReportData. So we might say to ourselves, well, what if other parts of the application need the ability to invoke this same getReportData method? Well, what we're going to do, just for reverse compatibility, if there's anywhere else in our software where we're relying on our iData access interface, is we're actually going to make sure that the iData access interface actually derives from the the iReportData access interface. And so now iData access is actually bringing along the iReportData access interface. So what we've got is we've got the best of both worlds here. We have a granular interface, iReportData access, that contains the data access method just required for us to go on ahead and get our data for our report. And we have the larger data access interface, which in turn brings along the iReportData access interface in order to bring the whole thing together, so that code that relied previously on iData access can still get its job done, but code that really only needs the report data part of this can actually simply implement the iReportData access interface. Because we've gone on ahead and taken our iData access interface and said that it implements the iReportData access, or derives from iReportData access, we should be able to actually still run our software exactly as before. Let's hit F5 and see what happens. And in fact, there it is. The code still works. So code that presently is written to depend on iData access can still do so and still work. However, now that we've got this more granular interface, the iReportData access interface, let's restructure our ReportData access class so that instead of requiring all of these extra implementations that we don't really want or need, just to have not implemented exceptions thrown because of its dependency on its inheritance hierarchy, let's get rid of these entirely. So we'll simply comment, let's get rid of these entirely. So we'll simply like that. And then what we'll do is we'll simply change the way this works so that report data access, instead of deriving from data access, can instead simply implement the iReportData access method, or interface rather. So now what we've got is report data access simply implements the lighter weight or segregated iReportData access interface, which has just the one getReportData method. It's allowed us to get rid of all this extra baggage. So now when we run the software, what happens, of course, is it doesn't work anymore, right? So what we've got to worry about here is we don't any longer have this override, because we're not overriding something in a base class. We're simply implementing it. So let's run the software again, see what happens. And in fact, it works. It still does formatting data for report 11 by 17. It says getting report to .matrix printer. All of the code still behaves exactly the same way. But we have simplified our dependency diagram by coming over here and modifying the way this thing actually behaves. So if we were to take, for example, our iData access interface and take our report data access and say move this type to a file so that we can easily come over here to our class diagram and take our iReportData access interface and add it to the, okay, code has errors. Why would that be? Let's rebuild it. There we go. Now we should be able to take our iData access, there we go, and put the interface there, right? If we take a look at it, we should be able to say show derived interfaces, and in fact there's our relationship between iData access and iReportData access. We also see that report data access now derives from iReportData access, and our data access abstract class can still derive from iData access. So all of that actually still functions. So what we've done is we've segregated our interface requirements into multiple smaller interfaces, each one with a much narrower goal. a much narrower goal in our software solution, and that is the whole notion of the interface segregation principle. The idea that things that implement interfaces ought not to have to bring along a lot of baggage that they don't need. And so by using smaller, more granular interfaces that are more narrowly focused on the task that's really needed, we can actually improve our design in that regard. And that takes us to the end of this particular screencast installment on the interface segregation principle.